welcome to today's video lecture. In today's video lecture, I'll be solving previous year's NEET questions and discussing the answers for the chapters you can see on the screen. Human Reproduction. We are in part 3 of the series. So if you haven't checked out part 1 and 2, please go and do so. I'll put the links in the description box below. Okay, so let's begin. Okay, so question number 1. About which day in a normal human menstrual cycle does rapid secretion of LH, popularly called LH surge, normally occurs? Okay, and this appeared in mains 2011. So our options are A, 14th day, B, 20th day, C, 5th day, and D, 11th day. Okay, so in a normal human menstrual cycle over here, we need to assume that the menstrual cycle is for 28 days because they haven't mentioned. Okay, and so in this case the rapid secretion of LH occurs on the 14th day. All right, so your answer is A. Let's go to the discussion. Okay, so in a menstrual cycle or an ovarian follicle cycle, LH begins to increase 2 days before ovulation, attains peak 16 hours before ovulation. Okay, so if this dotted line, I'm sure if you watched my videos, you'll be familiar with this. LH, now over there I have said 14th day, right? But the actual, for convenience sake, we always say LH surge will happen on the 14th day, that is on the ovulation, that's before ovulation. The surge is already started, it has not reached the peak. Okay, it has already started and remains peak 16 hours before ovulation. Okay, so we usually say that the LH surge, that is, it attains peak around the time of ovulation, because if LH surge did not happen, then ovulation wouldn't happen. Okay, so if we let's say in a 28-day menstrual cycle, LH surge occurs on day 14th. Okay, so it can't be 20th day, it can't be 5th day, 11th day. Now 2 days before, that means it should happen on the 12th day. If 14th day is the ovulation day, it should happen on 12th day. So 11th day also is incorrect. So 14th day would be the appropriate answer here. Okay, we have to take 14th day. We have to look at the best option available here, right? So yeah, so in a 20-day menstrual cycle, ovulation also we say occurs on the 14th day, but in this case we have to say the LH surge also happens on day 14, but the LH surge begins 2 days before. Let's say on the 12th day, if this is a 28-day cycle, from the 12th day onwards, 28-day cycles, it's in the 14th day, we assume that the ovulation is going to happen. Okay, so 12th day onwards, you see this blue line here, the surge is already started, right? Till and it attains peak 16 hours before ovulation. Okay, so it attains peak. Now with this peak, when it attains the peak, all those changes happen, right? The estradiol drops over here, progesterone also, you see a jump here, all that, and swelling of follicle also happens. All those changes happen, allowing for the Graafian follicle to release the oocyte. Okay, so clear, this was pretty direct, and you're familiar with the menstrual cycle and how it works. So we'll move on. Okay, so question number 2. Which one of the following is the correct matching of the events occurring during menstrual cycle? This appeared in 2009. A, proliferative phase, rapid regeneration of myometrium and maturation of Graafian follicle. B, secretory phase, development of corpus luteum and increased secretion of progesterone. C, menstruation, breakdown of myometrium and ovum not fertilized. Ovulation, LH and FSH attain peak level and sharp fall in the secretion of progesterone. Okay, so if you look at option A, proliferative phase, rapid regeneration of myometrium, that's incorrect, it's endometrium, so clearly A is wrong. Secretory phase, development of corpus luteum and increased secretion of progesterone, yes, that does happen during the secretory phase. Let's look at the other options. Option C, menstruation, breakdown of myometrium, no, that's incorrect, it's endometrium. And de-ovulation, LH and FSH attain peak level, and sharp fall, yes, they do attain peak level, both hormones. Obviously, LH is more. And a sharp fall in the secretion of progesterone, no, there's an increase in progesterone, so that is incorrect. C is also incorrect, so B is the right answer. So if you got B, you've got the right answer. Okay. So during the secretory phase, that means after ovulation and before menstruation, corpus luteum develops due to LH. We know that, we are aware of that, because LH has an influence. The Graafian follicle converts into corpus luteum and forms lutein cells. Okay. Estrogen secreted from the CL, that's corpus luteum, causes little cellular proliferation in the endometrium. Okay, so estrogen has, obviously estrogen is secreted from corpus luteum and it is less as compared to progesterone, but secretory phase, let's remember it this way, belongs to the progesterone hormone. Okay, and it's more about progesterone as compared to estrogen, because estrogen has done a job in the menstruation, the proliferative phase. Okay, it has restored the endometrium at that time. And now progesterone has to play a bigger role in the secretory phase. Obviously estrogen is secreted and it causes little cellular proliferation in the endometrium. Now progesterone, which has a major effect from corpus luteum, causes swelling and secretion of endometrial glands in the epithelial cells. This is very important. Okay, causes swelling and secretion of endometrial glands. Now what exactly happens is the stromal cell cytoplasm increases in size. This is what's happening. Lipid and glycogen deposits increase in the stromal cells. Blood supply to the endometrium increases. Okay, so these changes happen in the endometrium during the secretory phases. Remember it this way, that in the proliferative phase we were preparing the follicle also to develop, okay, into the Graafian follicle, so that the oocyte is released, right, during the ovulation. At the same time, menstruation has removed all the epithelial cells and everything. It has, desquatermized the whole structure of the endometrium. So now it's estrogen's job to regenerate all those cells. So estrogen plays a bigger role during that period, in the proliferative phase. Okay, and now when ovulation has happened, let's say the fertilization of ovum does happen during that time. Okay, ovulation has happened and the sperm's there and there is fertilization. So now we have a zygote, right? A zygote will grow in size and form an embryo. So secretory phase during those the rest of the menstrual cycle, the ovarian cycle, creates an environment in the uterus to allow or to nourish that growing embryo. Okay, if their implantation happens, if there's a zygote formed and it goes into the uterus and it implants there, it needs nutrition, right? It needs to grow there, correct? That's where a woman is pregnant. So basically every month progesterone is putting in all that energy in the endometrium and in the uterus to create an environment for the growing fetus. Obviously it does not happen every month, right? And there's no fertilization happening, so everything just comes out. All the epithelial cells and the blood vessels and all break and everything just slows off, okay, during the menstruation period. So let's remember it this way, that secretory phase allows for the swelling and secretion of endometrial glands. Okay, lipid and glycogen deposits are there, and stromal cell cytoplasm increases in size, and there's blood supply to the endometrium which increases. So all these changes are happening during the secretory phase, and progesterone plays a very big role during that time. You can also see in the menstrual cycle graph that progesterone levels are higher than estrogen during that period. So if you go back to our question, yes, development of corpus luteum and increased secretion of progesterone. Yes, that fits the answer. It's a correct match. Okay, clear? Let's move on. Okay, question number 3. Which one of the following is the most likely root cause why menstruation is not taking place in regularly cycling human female? And this appeared in 2009. Okay, so A, maintenance of the hypertrophical endometrial lining. It's not really the root cause for why menstruation is not taking place. B, maintenance of high concentration of sex hormones in the bloodstream. C, retention of well developed corpus luteum. And D, fertilization of the ovum. Okay, so if you'll go back to our question, it says why menstruation is not taking place in regularly cycling human female. That means her menstrual cycle is normal, right? She is regularly menstruating, but now we don't know why she's not, menstruating. But obviously, all the other like A, B, and C options do point out really to the hormonal balances or related to the endometrial lining, which does not fit the whole criteria of a person who's regularly cycling, as in a menstrual cycle, right? So the only option could be that there's fertilization of the ovum. Okay, so if your periods are appearing regularly like they should, and suddenly you don't have, and obviously if you're sexually active, um, there's a possibility that there is a fertilization of the ovum. Obviously they haven't mentioned all the other cases that, maybe she's sexually active, or whatever the case is, or the reason is. So apart from A, B, and C, it seems like D is the could be the root cause for that. Okay, so it's possible that there is fertilization of the ovum that's happened. Okay, so the answer is D. Obviously, maintenance of high concentration of sex hormones or retention of well developed CL corpus luteum, they don't really fit the criteria if a person is having her, female is having her periods regularly, because then her hormones and everything is balanced out. So, I believe that, yeah, D is the appropriate answer here. There's fertilization of the ovum. Okay, so if a woman is menstruating regularly, then the root cause for no menstruation could be fertilization of ovum, like I've already explained. Okay, clear? So, if a woman does get pregnant and fertilization of ovum happens and implantation happens, the corpus luteum does not degenerate. It secretes progesterone during pregnancy to maintain it, and remains active up to 10th to 12th week of pregnancy. And thereafter, the functions are taken over by placenta. Okay, so this is it. Okay, next question. Question number 4. Which one of the following statements is incorrect about menstruation? So to find the incorrect statement, and this appeared in 2008. A. At menopause in the female, there is specially abrupt increase in gonadotropic hormones. Yes, that's true. The beginning of the cycle of menstruation is called menarche. Yes, you should know that. That's true. C. During normal menstruation, about 40 ml of blood is lost. Yes, that's correct. D. Menstrual fluid can easily clot. No, that's incorrect. Menstrual fluid does not easily clot. So D is the right answer. Okay, let's go to the discussion. The menstrual fluid is non-clotting. Okay, that's how it comes out, and due to the presence of fibrinolysin. Okay, so there is this fibrinolysin enzyme over here which does not allow clotting of menstrual blood, and is released along with the dead endometrial lining. Okay, so the endometrial lining, the cells and all are coming out, blood is also coming out, but it does not allow for the menstrual blood to clot because of fibrinolysin. Okay, now before we move on to the next question, I thought I'll talk about menopause, so you know exactly what happens in menopause. So menopause is a period during which the menstrual cycle stops and the female sex hormones diminish to almost none. So it usually happens in females above 40, like 40 to 50 years of that age gap. And we are aware of the fact there are primordial follicles or oocytes already present at the time when the fetus is being developed, right? So when the female child is born, she already has the oocytes that she will carry with her for the rest of her life, correct? So but obviously, yeah, by the time she achieves puberty also, many ovas are degenerated, and by the time she achieves puberty and goes through every menstrual cycle, she is losing out on those oocytes, right? So by the time she reaches 45 or 40 or 45 to 50 years of age, by then there are very few primordial follicles remaining inside the ovary. Also, estrogen levels, they begin to decrease slowly and slowly, and at one point of time they stop producing, the ovaries stop producing estrogen. So basically the ovaries burn out. Okay, that's what the term that's used in medical textbook. They burn out. Okay, they're exhausted. So primordial follicles are very few, so that means ovulation is not happening. Ovulation is not happening, that means your menstrual cycle is becoming irregular. Okay, so that's a sign of menopause when you've reached that age. So no ovulation takes place and the cycle becomes irregular. Also, very few primordial follicles are left on which FSH and LH can act, right? So the burning out, like I said, the burning out of ovaries ceases secretion of estrogen, and hence the negative feedback loop is activated, allowing for FSH and LH to secrete from pituitary gland. So what happens is, now if estrogen usually has a ability to create a negative feedback loop, right? It stops, if there's too much estrogen, it will stop FSH and LH secretion from the anterior pituitary, and also to a certain extent acts on hypothalamus, right? But let's say if estrogen, now the ovaries are burned out, so estrogen is not being produced from the ovaries, right? So the negative feedback loop is stopped, right? So the negative feedback loop is stopped. What happens is, estrogen now, there's no way that estrogen can stop FSH and LH from secretion. So FSH and LH begins to secrete. Mostly it's FSH majorly. That's what I mentioned here. And so if you'll go back to the question, it said that gonadotropic, at menopause in the female, there is especially abrupt increase in gonadotropic hormones. So this is the reason. Okay, so don't think that gonadotropic hormones decrease. No, they in fact increase during that time. Now, what are the physiological changes due to low estrogen? Now, low estrogen happens in females during that period. Now, what are the changes that are happening due to that? This flushing of skin, this hot flushes. Okay, so there's heat, or a woman feels very hot around her face, torso area. Then the psychic sensation of dyspnea, that is shortness of breath. So she feels like there's shortness of breath. There's irritability, there is anxiety, there's fatigue, and there's decreased strength and calcification of bones. I think we already discussed this in locomotion and movement, right? Osteoporosis happens. So due to low estrogen. So this is during that period of time, okay, that when she has achieved menopause. So basically this is what happens during menopause. I thought I'll explain this to you so that you understand if you ever get a question regarding menopause in the exam. Okay, clear? I guess we've answered the question. Okay, I guess we can move on. All right, question number 5. Which part of ovary in mammals acts as an endocrine gland after ovulation? 2007. This is easy. So A, stroma, B, germinal epithelium, C, Vitelline membrane, D, Graafian follicle. Yes, it's Graafian follicle, which converts to corpus luteum and which acts like an endocrine gland. We discussed this many times, so it's probably a revision. After ovulation, Graafian follicle gets converted to corpus luteum in the ovary. The granulosa cells secrete progesterone and estrogen, and theca cells secrete androgens, which convert to estrogen in granulosa cells via the use of aromatase. So you are already familiar with this if you've been following my videos on what this means, right? So I will not go through this again. Also, inhibin is also secreted by the corpus luteum from the granulosa cells. That's one more hormone that is secreted. So the corpus luteum behaves like an endocrine gland. All right, clear? So this was a repetitive question. We've discussed this many times. Okay, question number 6. In the human female, menstruation can be deferred by the administration of, this appeared in 2007, A, combination of FSH and LH, B, combination of estrogen and progesterone, C, FSH only, and D, LH only. Okay, so if you want to defer the menstruation, what do? So a combination of estrogen and progesterone can help defer that. Okay, so the answer is B. Okay, so combination of estrogen and progesterone hormone can be administered to defer menstruation. The loss of these hormones causes menstruation, but if they were administered externally, then menstruation can be deferred. Sorry. So I will not explain this much in detail. I'll go through the next question because I've already explained that, and I've also discussed this in the previous part on how menstruation begins, right? So corpus luteum is there, and corpus luteum regresses as involution of corpus luteum happens, because of which menstruation begins. So combination of progesterone and estrogen can help maintain the endometrial lining, so that will not allow menstruation to happen. Okay, but let's go to the next question so you'll understand this better. Okay, so question number 7. Withdrawal of which of the following hormones is the immediate cause of menstruation? This appeared in 2006. A. Progesterone, B. Estrogen, C. FSH, and D. FSH-RH. So withdrawal of which of the following hormones? It's A. Progesterone. Okay, if you have to choose between A and B estrogen, it's A. Progesterone. Answer is A, and we'll see how. So menstrual flow, is due to lack of progesterone, estrogen, and inhibin from the lutein cells, right? So Cl secretes all these hormones, okay, but progesterone mostly. Okay, so if you look at the menstrual cycle, see progesterone is at a higher range as compared to estrogen, right? So progesterone mostly, that's why we selected progesterone as the answer there. Now, estrogen majorly and progesterone decreases FSH and LH secretion. Now, please don't get confused. Estrogen majorly has a more influence on the pituitary and the hypothalamus as compared to progesterone. But when estrogen and progesterone combine together, they have a stronger effect on the pituitary and the hypothalamus glands. Okay, so estrogen majorly has a direct impact on the pituitary, so that causes decrease in secretion of FSH and LH. Now, inhibin decreases FSH secretion. We already discussed this before. Now, final degradation of corpus luteum occurs 2 days before menstruation. Okay. Now, the regression of corpus luteum is due to fall in LH and high levels of PGF2 alpha and estrogen. Okay, so there's fall in LH. Yes, we are aware of that because of estrogen and progesterone acting on the pituitary gland. But there are high levels of PGF2 alpha. Estrogen obviously is high, as in it is being secreted by corpus luteum, not as high as progesterone, but it is being secreted by corpus luteum and does have an impact in causing the regression. Okay, and also there are high levels of one more hormone called prostaglandin. Okay, so that is secreted from the uterine walls. Okay, there's one more hormone called prostaglandin, which also has an effect or an impact on corpus luteum's regression. Okay, so when prostaglandin has an impact, there's high levels of estrogen also. Yes, estrogen is also having an impact in causing the regression of corpus luteum, and obviously there's fall in LH. Okay, so to the cessation of progesterone, sorry, I'll just get rid of this. So the cessation, that means the stop of progesterone, estrogen, inhibin results in menstruation and the beginning of the next ovarian cycle. Obviously, progesterone comes first because it is secreted highly, as in more amount by corpus luteum as compared to estrogen and inhibin. Okay, so progesterone has a more impact in causing the menstruation to happen. Okay, obviously it does not have a major impact in acting on the pituitary gland, nor does it have a major impact in causing the regression of corpus luteum. But if corpus luteum disappears, progesterone or regresses, progesterone will immediately drop, and that is causing menstruation. That is the bleeding. The endometrial lining slows off from the uterus. Okay, so that is what is menstruation. Okay, so now when we go back to the previous question, we said that administration of estrogen and progesterone. Now there are pills available which have a combination of both these hormones. They're synthetically made, and they can then in turn maintain the endometrial lining and not allow it to slow off. Okay, so that means the menstrual flow can be deferred if you want to. So, but please speak to your doctor before you take any action yourself. Please don't do it on your own. But yeah, to answer your question, withdrawal of which of the following hormones is the immediate cause of menstruation? That is progesterone. Okay. Yeah, let's go to the clear. I guess this was clear. This also has been discussed in the previous part, and it is a repeat of that. Yeah. Let's move on. Okay, question number 8. If mammalian ovum fails to get fertilized, which one of the following is unlikely? This appeared in 2005. A. Corpus luteum will disintegrate. B. Progesterone secretion rapidly declines. C. Estrogen secretion further increases. D. Primary follicle starts developing. So, if a mammalian ovum fails to get uh, fertilized, which of the following is unlikely? Corpus luteum will disintegrate. Yes, corpus luteum will happen. Will disintegrate. Yes, that's true. Progesterone secretion rapidly declines. Yes, that's true. Estrogen secretion further increases. No, estrogen secretion also declines. Primary follicle starts developing. Yes, if the mammalian ovum fails to get fertilized, then menstruation happens. So primary follicle starts developing again then. But if mammalian ovum fails to get fertilized, which one of the following is unlikely? So menstruation to happen, estrogen should not increase. In fact, it should decrease, right? So only then menstruation will happen, like we've seen in the case of corpus luteum, right? So C is the right answer here. So it is unlikely that estrogen secretion further increases. Oops, sorry. Answer is C. These are good questions because they help you think. So this was a good one. If the ovum does not get fertilized, then estrogen progesterone levels decrease, leading to menstruation. Now menstruation happens, primary follicles will again begin to develop, right? During the menstruation phase itself, now estrogen progesterone are not, the inhibin is also not there because corpus luteum has disintegrated. So again FSH and LH begin to secrete from the pituitary gland, and the next phase, it begins to prepare for the next menstrual cycle, right? So also it needs to also develop the endometrial lining again. Obviously after the slowing off happens, again endometrial lining also begins to restore itself, right? But that happens later on. But if the ovum does not get fertilized, yes, then estrogen progesterone levels decrease, leading to menstruation. One second, let's go back to the question. Okay, so we have answered this, that it is, which of the following is unlikely, right? So estrogen secretion further increases, that's unlikely. That will happen later on. Okay, let's move on then. Question number 9. Ovulation in the human female normally takes place during the menstrual cycle. 2004, this appeared in 2004. Ovulation will take place at the mid-secretory phase. No, that's not true. B, just before the end of the secretory phase. No. At the beginning of the proliferative phase. No. At the end of the proliferative phase. Yes, that's right. Answer is B. So if you go back to your menstrual cycle graph, you can go back and look at it. Ovulation takes place at the end of the proliferative phase. This was a pretty direct, easy question to answer. Let's move on. Okay, question number 10. Identify the human developmental stage shown as well as the related right place of its occurrence in a normal pregnant woman and select the right option for the two together. Okay, so we have the diagram here, and we have the developmental stage and site of occurrence. So A, late morula, middle part of fallopian tube. B, blastula, end part of fallopian tube. C, blastocyst, uterine wall. D, 8-celled morula, starting point of fallopian tube. So this diagram over here represents the blastocyst. Okay, and site of occurrence is uterine wall. So the answer is C. This appeared in mains 2012. Okay, let's go to the discussion. So after fertilization, okay, now the zygote has been formed. The sperm has entered this fusion of nucleus, and we have formed the zygote. Okay, so after fertilization, zygote. Now this is a story after that. Okay, zygote divides mitotically to form two blastomeres in about 30 hours. Okay, so in 30 hours after the fertilization, the zygote divides mitotically to form two blastomeres. Now, each cell contains equal cytoplasmic volume and chromosome number. So, obviously, yeah, they're mitotically divided. So, the two blastomeres, I have a diagram which will be coming up soon, photograph of that. They are equal in the cytoplasmic volume. The volume is the same and the chromosome number is the same too. The blastomeres divide by binary division. So now 2 become 4, then they become 8, then 16, till it forms a morula. Morula is like the 16 to 64 cell stage. So now after 3 days, now 3 days have passed in the fallopian tube. All this development has happened in the fallopian tube. Okay, it has formed the morula. So after 3 days in the fallopian tube, the morula enters the uterus on the 4th day at 16 to 64 cells stage. Okay, so so the zygote has been formed. After 30 hours, the blastomeres have formed, and then they begin to divide mitotically to 2, 4, 8, 16, 32, 64 and all. So finally, when it forms the 16 to 64, after 3 days that it has spent in the fallopian tube, the morula enters the uterus on the 4th day at the 16 to 64 cells stage. Still the morula, okay, and it has entered the uterus. Now the transport is a slow process. This whole transport of the zygote through the fallopian tube and into the uterus is a very slow process, okay, and is controlled by the contraction and movement of cilia. Okay, so the cilia controls the contraction and movement. The morula remains free till the 4th to the 5th day and is covered by a mucus film which enters the morula via the zona pellucida. Okay, so you know the zona pellucida is still around that, right? Around that zygote inside, right? Now, morula remains free in the uterine tube till the 4th to 5th day and it is actually covered by a mucus film. Okay, and now which enters the morula. Now, this fluid part enters the morula through the zona pellucida canaliculi. Okay, there are passageways by which it enters via the zona pellucida into that morula. Okay, and separates the cell. Okay, it begins to separate the cell, and now this stage is called blastocyst. So now the morula remains free till the 4th to 5th day and is covered by a mucus film. Now this mucus fluid enters the morula via the zona pellucida canaliculi, okay, the passageways. Now once it enters, this allows for separation of all the cells. Okay, this allows for the separation of all the cells and is now called blastocyst. So the structure that you get is called a blastocyst. Yeah, so you see a diagram over here. So you see the blastomeres over here. This is the initial, that's after 30 hours of fertilization. This is produced with 2 blastomeres, then becomes 4, then finally it forms a morula. What you see here is a morula, okay, which enters the uterus, right? And over here what you see, D structure D here, is called blastocyst. Okay, this whole structure is called blastocyst. And if you are curious, I've taken this from a textbook called Datta, which is a textbook of gynecology. Okay, just in case you want to know. Now, the enlargement of blastocyst causes lysis of zona pellucida and escaping of embryo, which is called zona hatching. Now, the zona pellucida is still there, right? And obviously, the mucus that is gone in is allowing the separation of cells inside. Okay, now they are going to be assigned functions inside that, but the zona pellucida will not remain there forever, right? It has to disintegrate, it has to come out. So what happens is the blastocyst inside enlarges, okay, causes lysis of the zona pellucida. So blastocyst increases in size and the lysis of zona pellucida happens, which allows for the escaping of embryo. Okay, so just now we don't see the zona pellucida in this, but just imagine if zona pellucida was surrounded here. This causes lysis of the zona pellucida and the embryo escapes from there. Okay, this is called zona hatching. Now, the inner cells in the morula. Now you say that I told you, right, the separation of cells happening inside when the fluid, the mucus enters through the zona pellucida. The inner cells of this morula are assigned a job. Okay, they become the inner cell mass. Okay, the inner cells become the inner cell mass, which forms the embryo, which eventually forms the embryo. Okay, so this is the embryo blast here. Over here, the inner cell mass. And this structure that you see, so the outer cells of the morula, they form the trophoblast, okay, which differentiates into chorion, which eventually form the placenta. Okay, so you see the outer cells of the morula, once the zona hatching has happened, they form the, actually the blastocyst is already formed inside the zona pellucida. The only now job is to escape from the zona pellucida. So the lysis of zona pellucida happens because the blastocyst increases in size. Okay, so till then all the differentiation has already happened. Now who has to do what job? Now morula has all these 16 to 64 cells right inside that. Now it is dividing continuously, because obviously the blastocyst is eventually increasing in size along with that. So the inner cells of those morula, once it becomes a blastocyst, the inner cells become the embryo. They form the inner cell mass, which eventually becomes the embryo, and the outer cells, they form the trophoblasts. Okay, the trophoblasts are the cells which will differentiate into chorion, which forms the placenta, which help in the implantation, okay, into the uterine wall. Okay, so this is what blastocyst is, and this is how blastocyst is formed. If you go back to our question, yeah, blastocyst and site of occurrence happens in the uterine wall. Okay, so it remains free. Like I said, the morula remains free till the 4th day, and then after that, blastocyst stage happens. Okay, so this is a diagram from NCRT. So if you've been studying NCRT, which you have to for NEET, you will see this. You'll be familiar with this. So it basically just explains everything. This fertilization, and then the blastomeres are formed, and the morula stage is formed, and then eventually, yeah, this morula increases in size, as in, more cells are formed, and then finally blastocyst is formed here. See, the morula has entered the uterine wall, and here is the blastocyst over here. Okay, so how is the blastocyst formed? This is how the blastocyst is formed. Okay, the after the obviously after zona hatching is when the implantation will happen. Okay, the morula cells inside have, when the fluid enters, have already differentiated into what job they have to do. When the blastocysts keep increasing in size, all these cells then rearrange themselves and they form the blastocyst structure that you see. Okay, so this inner cell mass that you see here will form the embryo, and the outside one forms a chorion, develops into the chorion, which allows for the attachment. See, you can see the attachment over here, blastocyst implantation. Okay, so this pretty much answers our question. We will move on then. Okay, question number 11. Which set is similar? This appeared in 2001, and I'm sure you're familiar with this question because it's appeared in endocrine system also. Which set is similar? Corpus luteum, graphene follicles, sebum, sweat, bundle of his, pacemaker, vitamin B7, niacin. So A is the set which is familiar. Corpus luteum, graphene follicles transform into corpus luteum. Sebum and sweat are two different things. Bundle of his and pacemaker are two different things. They form the structure of the heart. Vitamin B7 and niacin are two different things. So the answer is A. So graphene follicles after ovulation convert to corpus luteum. Sebum is an oily substance produced in the sebaceous gland. Pacemaker is SA node in the heart, and bundle of his is a part of the electrical system of the heart and conducting nerve impulses. Vitamin B7 is biotin, and niacin is vitamin B3. Okay, so option A was the appropriate answer here. All right. Let's move on then. Okay, question number 12. After ovulation, Graafian follicle regresses into, it's appeared in 99, A. Corpus artesia, B. Corpus callosum, C. Corpus luteum, D. Corpus albicans. Now, regresses is not really the right term to use. Graafian follicle transforms or converts into corpus luteum after ovulation. Okay, so your answer is C. Okay, direct question. We are familiar with this, right? After ovulation, Graafian follicle transforms into corpus luteum. Okay, and the corpus luteum behaves like an endocrine gland. All right, let's move on then. Question number 13. In the fertile human female, approximately on which day of the menstrual cycle does ovulation take place? This appeared in 97. Okay, so we are assuming that this is a 28-day menstrual cycle and ovulation will take place on day 14 because they haven't specified how many days is the menstrual cycle, right? So we're assuming that's a 28-day menstrual cycle and on day 14 ovulation will happen. So answer is A. Okay. In a 28-day menstrual cycle, ovulation takes place on day 14th. Direct, easy question. Ovulation occurs 14 days before the next menstruation date. This information is very important. Okay, ovulation will always occur 14 days before the next menstruation date. Now, please write this if you know the answer. If the menstrual cycle of a female was 40 days, then when will ovulation occur? Okay. Similarly, if the menstrual cycle was 35 days, then when will ovulation occur? Let me know in the comment section. All right. Because this is very important. Here they haven't specified, we are assuming it's 28 days, but if they say in a 40 days menstrual cycle or in a 35 days or in a 26 days menstrual cycle, it could be anything, we don't know, because it can vary from female to female, right? So if it was 40 days, then what would you say? If it was 35 days, if it was 26 days, what would be the ovulation cycle, ovulation day, sorry. All right, so let me know in the comments below. Okay, but in a 28-day menstrual cycle, ovulation takes place on day 14th. So, yeah, ovulation takes place on day 14th. Yeah, that's the appropriate answer here. So, answer is A. Let's move on. Okay, question number 14. The mammalian corpus luteum produces, and this appeared in 95, luteotrophic hormone. Sorry, luteotrophic hormone, B. luteinizing hormone, C. estrogen, and D. progesterone. So, mammalian corpus luteum produces now. There's estrogen. It produces estrogen. It produces progesterone, but it produces progesterone in higher amount as compared to estrogen. So, I would choose progesterone. That is the appropriate answer for this question. Okay, but yeah, in NEET always then stick with progesterone. So corpus luteum secretes progesterone, estrogen in a bin. We are aware of that. Oops, sorry. But yeah, since estrogen is also present there, but yeah, I would tell you or advise you to choose progesterone because that is produced in higher amount. Okay, question number 15. In the 28-day human ovarian cycle, the ovulation takes place typically on, and this appeared in 94. Okay, so here they've specified 28-day human ovarian cycle. The ovulation takes place on day 14 of the cycle. Okay, answer is A. Now, please don't assume it's always 28 days. 28 days is just an example given to you, right? But it could be a 40-day cycle. If they ever ask you 26-day cycle and when will ovulation occur, you should be able to answer that, right? Ovulation takes place on day 14 in a 28-day human ovarian cycle. Okay, we've discussed this many times. So let's move on. Okay, so question number 16. Extrusion of second polar body from egg occurs, and this appeared in NEET 2019 and also in 93. A. Simultaneously with first cleavage. B. After entry of sperm but before fertilization. C. After fertilization. D. Before entry of sperm into ovum. Okay, so extrusion of second polar body from egg occurs after entry of sperm but before fertilization. So the answer is B. So meiosis 2 is completed after the entry of sperm into the ovum, and this forms the mature ovum and second polar body, and then the second polar body is extruded. That means it is removed. Okay. Only then after that the mature ovum is formed, then the fusion of the nucleus will take place. Okay. Before that, it will not happen. So entry of sperm is required for meiosis 2 to be completed, but fertilization has not happened as yet. Only when the meiosis 2 is completed, mature ovum is formed, only then fertilization will happen. So it happens after the entry of sperm but before the fertilization. Okay, let's move on then. Okay, question number 17. Capacitation occurs in, and this appeared in NEET 2017, A. Epididymis, B. Vas deferens, C. Female reproductive tract, and D. Reti testes. So capacitation, they're talking about sperms, right? It occurs in C. Female reproductive tract. Okay, so capacitation of spermatozoa occurs in the female reproductive tract in 1 to 10 hours. Now, what happens during capacitation? Initially, the sperm is not able to fertilize the ovum after it has entered the female tract. Okay, the changes that the sperm undergoes is called capacitation of sperm. So, as when there's ejaculation, immediately they are not in the position to fertilize an ovum, right? So, capacitation of spermatozoa needs to take place to be able to perform fertilization with the ovum. Now, what are the changes? They include, now the fluids in the fallopian tube and uterine wash away the inhibitory factors that suppress the sperm activity. So when the sperms are in the epididymis, they are surrounded by some inhibitory factors. Okay, so now when they are ejaculated in the female tract, now there are fluids present in the fallopian tube and the uterine cavity which wash away all those inhibitory factors. Okay, that suppress the sperm activity. Now, in the male genital ducts, the sperms are covered with floating vesicles surrounded by cholesterol. Okay, and this makes the acrosome tough, preventing release release of enzymes. So, when they are in the male tract, they are surrounded by floating vesicles that contain cholesterol, and that makes the acrosome. Now, acrosome is a place on the head where the enzymes are present, which is necessary for fertilization to happen. So, it makes the acrosome very tough. Okay, so but after entering the female tract, the sperms swim away from the vesicles, making the acrosome weak so that they are able to fertilize the ovum. Okay. Now the third change is the sperm becomes permeable to calcium ions, thus strengthening the whiplash motion of the flagellum. Okay, so calcium ions becomes permeable to calcium ions increase the whiplash motion of the flagellum. Also, it causes changes in the membrane, allowing for acrosome to release enzymes rapidly. All right, and obviously, when it allows for enzymes to release rapidly, it will allow for penetration also into the granulosa cells and also the zona pellucida for fertilization to take place. So, this is what capacitation includes. Okay, these three changes. You can note them down. This will be very helpful for your exam to learn. I guess I've pretty much answered the question. Capacitation occurs in the female reproductive tract. Okay. All right. Question number 18. Fertilization in humans is practically feasible only if, it's appeared in NEET 1 2016. A. The ovum and sperms are transported simultaneously to ampullary isthmic junction of the cervix. No, that's incorrect. B. The sperms are transported into the cervix within 48 hours of release of ovum and uterus. No, that's incorrect. C, the sperms are transported into the vagina just after the release of ovum in fallopian tube. No. D, the ovum and sperms are transported simultaneously to ampullary ischemic junction of the fallopian tube. Okay, one thing that I want to correct, I don't know why they have written ampullary ischemic junction, but fertilization always takes place in the ampulla. Please remember that, okay, not the ampullary ischemic junction. Okay, fertilization, if it has to happen, always happens in the ampulla region of the fallopian tube. I don't know why they have mentioned this ampullary ischemic junction. But yeah, if fertilization in humans is practically feasible, that's the question. Now it's practically feasible only if the ovums and sperm are present simultaneously at the same time, right, in the fallopian tube. Only then fertilization is going. We're sure that fertilization will happen, right? But if the sperms are transported in the vagina just after the release of ovum in fallopian tube, we don't know how many hours have been elapsed, because the ovum is viable only for 12 to 24 hours for fertilization, right? Also the sperm, although the sperm can live for 24 to 48 hours, even up to 5 days, a few sperms only, but we don't know how much time has elapsed between the transport of the two. Okay, so C is not an appropriate answer, but D, if you do this practically, yes, it is feasible. The ovum and sperms are transported simultaneously to the ampulla junction, ampulla of, part of the fallopian tube. So the answer is D. Okay, so fertilization is practically feasible when both ovum and sperms are released simultaneously into the ampulla region of the fallopian tube. That's where the fertilization will happen. Okay, so clear? Can move on. Question number 19. In human females, meiosis 2 is not completed until, this appeared in 2015. Meiosis 2 is not completed until A, uterine implantation, no, B, birth, C, puberty, and D, fertilization. It is D, fertilization. Okay, so answer is D, that's the appropriate answer. Now, meiosis 2 is not completed until sperms enter the secondary oocyte for fertilization. Okay, fertilization has not happened as yet, but if the sperm enters the oocyte, the zona pellucida, only then meiosis 2 will be completed to form and mature ovum, and then fertilization will happen. Okay. Okay, clear? Let's move on. Question number 20. Capacitation refers to changes in the, we just discussed capacitations, appear in 2015, so cancelled exam. A, ovum after fertilization, B, sperm after fertilization, C, sperm before fertilization, D, ovum before fertilization. We know capacitation occurs in sperms, so it happens in sperms before fertilization. Yeah, answer is C. So it refers to the change in sperm before fertilization. I've already mentioned what changes occurs. You can go back and watch that explanation again. Okay, let's move on. Okay, question number 21. In our society, women are blamed for producing female children. Okay, choose the correct answer for the sex determination in humans. And this appeared in Karnataka NEET 2013. Okay, this is a very harshly stated question, but we get the gist of what NEET is trying to ask us and what they want to test us on. So to choose the correct answer for the sex determination in humans. Okay, so A, due to some defect like aspermia in man, sorry, in males, that is man. B, due to the genetic makeup of the particular sperm which fertilizes the egg. Okay. C, due to the genetic makeup of the egg. D, due to some defect in the woman. So obviously it's B, due to the genetic makeup of the particular sperm which fertilizes the egg. So the answer is B, and we'll see how. So the human chromosomes contain one pair of sex chromosome. In males it is XY, and in females it is XX. So we have 23 pairs, right? We are all diploid individuals. We have 23 pairs of chromosomes. So in males it is X and Y. Okay, they appear in pairs, and females it is XX. So if you're a female, you will have XX chromosome, and in males it is XY chromosome. Okay. Now during spermatogenesis, now the formation of a haploid cell, the mature sperm, now we know that from diploid it becomes haploid, right? So the mature sperm will carry either X or Y chromosome in its haploid cell. Initially the spermatogonia and all had diploid, it had XY, but now when it's become haploid, it will carry either X or it will carry either Y. Okay, that's haploid. Now it doesn't have 23 pairs of chromosomes, it has only 23 chromosomes in it, right? It's only half of 46, so it has only 23 chromosomes in it, so it will carry either X or it will either carry Y chromosome. In oogenesis, the females don't have much option, right? It's X and X, so both of them will have X. The ovum will carry X chromosome only in its haploid cell, right? So when the ovum is formed, it will carry X. There's no other option. At fertilization, the fusion of male and female nucleus results in the formation of diploid cell, right? So which will contain either XX pair of chromosome or XY. So one X is coming definitely from the female, okay, because she doesn't have any option. Now the second chromosome to form the 23 pairs will be either X or it will be either Y, depending on which sperm is fertilizing the egg at that time, the ovum at that time, right? So finally the diploid embryo that is formed will have either XX pair of chromosome, it will have either, or it will have XY pair of chromosomes, right? So if it's XS, it will be form a female child, and if it's XY, it will be a male child. So if it is XX, then it is female child, and if it is XY, it is a male child. So hence the X or Y chromosome is added by the sperm and hence determine the sex of the fetus. So the X or the Y chromosome is determined by the sperm cell, not the ovum. Okay, so that is why it is determined by the father of the child and not the mother. The mother already has XX chromosome. She doesn't have many options, but the male has, the sperm cell has either X or Y. So when the mature sperm cell is formed, that will eventually fertilize with the ovum, it will carry either X or it will carry either Y chromosome. Okay, so if X fertilizes with the X, so it will form a female. If the sperm cell has Y chromosome, it fertilizes with the X, it will form a male child. So the onus is on the father of the child and not the mother of the child. That's what basically they're trying to ask here. Yeah, the NEET probably has a very harsh way of questioning the person whoever prepared the question. But anyway, so basically this is what they want to imply here, okay, in this question. All right, so clear. If you go back to the question, our society, choose the correct answer for the sex determination in humans. So it's due to the genetic makeup of the particular sperm which fertilizes the egg. Okay, that is the correct answer. All right, clear. All right, okay, so we've come to the end of this video lecture, and I hope you've enjoyed today's video lecture, and I hope you've learned something new today. And don't forget to like, share and subscribe to MJ NEET Biology. And I'm also available on Twitter, Facebook and Instagram, so you can follow me there for more updates. And I'll see you in the next video lecture, right? So bye.